All right, so now that you understand one-sided limits, we can take what you know about one-sided limits and very easily transmit it to understanding two-sided limits. Okay. Now I want to remind you that the way a one-sided limit and a two-sided limit appear, what they look like on paper, if we had like the limit as x approaches 2 from the right of, let's say, 4x over x minus 7. Okay. Let's say that this is our limit. Okay. That it's a one-sided limit if it has this little superscript here, right? If it says 2 from the right, or if it said 2 from the left, right? Then it's a one-sided limit. And then a two-sided limit very simply just doesn't have this superscript. It just says the limit as x approaches 2. So when it doesn't have the plus or the minus here, it means approaching 2 from both the left side and the right side. Approaching 2 from both sides, meaning a two-sided limit, okay? So that is just a quick review of what it looks like. So let's look at these tables here. Let's say that we have some function f of x, and we have some x values here, and we have some output values for f of x, given these input values. Then we have, for the same function f of x, we have other input values and some output values. So if we look at this, it looks to me like, what is x approaching here? We got 5.9, 5.99, and 5.999, right? Looks like x is approaching 6, right? So in this case, it's going to be a limit of f of x, because it's the function f of x, as x is approaching 6. And what side is x approaching 6? Well, these numbers are smaller than 6, so it's approaching 6 from the left. So we'll put a little minus there, right? And it looks to me like, let's see what f of x is approaching. As x is approaching 6, it looks to me like f of x is approaching, we got negative 18.15, then negative 18.015, then negative 18.002. It looks like we're getting closer and closer to negative 18, right? So it looks like the limit is negative 18. So we've got our solution to this left-sided limit on f of x, that is x is approaching 6 from the left, f of x is approaching negative 18, okay? All right, let's look at this other one over here, same function, but the inputs we're using are 6.1, 6.01, and 6.001. All right, well, it looks like these x values are also approaching 6, but they're approaching from the right side because these numbers are larger than 6. So we're going to say limit as x approaches 6 from the right, okay? Of what function? Of f of x. Well, let's look at that. Let's see what f of x is approaching as x approaches 6 from the right side. Well, we've got negative 17.85, then negative 17.98, and then negative 17.99. It looks like these numbers are getting really close to negative 18, which you may recall was the answer to the first one that we had. And so, look at this. We have our left-sided limit. On the left side of 6, f of x is approaching negative 18. On the right side of 6, f of x is also approaching negative 18. And so what we now can do is we can now write a two-sided limit as x is approaching 6, because we know what x, we know we can see x is approaching 6 from the left and x is approaching 6 from the right. And so we can now say, well, what is the limit of f of x? This is really ugly. Sorry, folks. It's really hard to reach in from the right. And whenever I walk in front, it always messes up the lighting of the video. So I'm sorry about that. So the limit of f of x as x approaches 6, now I'm not going to put a plus or a minus, because we're now going to be talking about as x approaches 6 from both sides. And here's the rule on two-sided limits. That if the limit approaching from the left is the same limit as x approaching from the right, I don't mean the same number here. That's obviously going to be the same number. I mean if the answer is the same for both of them. So we can see that the limit from the left is negative 18 and the limit from the right is also negative 18. If both of those one-sided limits are the same answer, then that means that the two-sided limit exists and it is that very same number. And therefore, the two-sided limit in this particular case is going to be negative 18. And so now you know that all you really have to know how to do is, in order to answer a two-sided limit, you just have to know what the left side answer is and what the right side answer is. And if they're the same answer, then the answer is going to be whatever that number is, okay? So let's do a few examples, not large-scale examples. I'm just going to sort of give you this number and give you this number, and you tell me what the limit is. All right, so let's try this one. So I'm just going to tell you that the limit of the function k of x as x approaches negative 12 from the left side. So we have negative 12 with a minus there at the top. So that's indicating from the left side, approaching negative 12 from the left, that the limit of k of x is 2. All right, now we have the limit of k of x as x approaches negative 12 from the right side, okay, is also 2. So the question is, what is the limit of k of x as x approaches negative 12? Now it's a two-sided limit. What is the limit of this function as x approaches negative 12 from both sides? Well, from the left, the limit is 2. From the right, the limit is 2. And therefore, there is a two-sided limit, and the limit is 2. Okay? All right, let's try a couple more examples. All right, so here's another one. I challenge you to pause the video and see if you can figure this one out on your own. All right, so let's see here. We've got some information. We have the limit of the function g of x as x approaches 5 from the left. So, you know, x is approaching 5 from smaller numbers like 4.9, 4.99, 4.999. And when we do that, we find that the limit is 8. Okay, the function is approaching an output value of 8 as x is approaching 5 from the left. But when we go to the same function and we approach 5 from the right, so we're talking 5.1, 5.01, 5.001, okay, by numbers that are larger than 5 but coming backwards to 5, getting closer to 5. We find that the output is approaching 11. Okay, so there's something weird happening in this function. That from the left, that function is approaching 8, but from the right, that function is approaching 11. And so now when we ask, well, what is the limit of the function as x approaches 5? Well, the two sides don't agree, okay? So the left side is approaching 8 and the right side is approaching 11, okay? And since they're not approaching the same number, you might be thinking something crazy like, what is it, some number between 8 and 11? No, those two numbers have to be the same in order for this limit to exist. And therefore, even though we have a one-sided limit on the left and we have a one-sided limit on the right, because they are not the same limit, there is no two-sided limit. We would say no limit. That's one way of saying it. Or a lot of times we say DNE, which means does not exist. The limit does not exist. Sometimes we'll say that the limit is non-existent. I usually just say that there is no limit, okay? And so I'm clarifying to you here that if the one-sided limits, if the left side and the right side are not the exact same number, then there just isn't a two-sided limit. The two-sided limit does not exist, okay? Let's try one more example. All right, so here's another one. If you want to, you can try it yourself. Go ahead and pause it and see if you get the right answer. All right, so here's what we have. We have the function h of x, okay? And we have the limit as x approaches 1 from the left, and we have the limit as x approaches 1 from the right. Well, as x approaches 1 from the left, like 0.9, 0.99, 0.999, okay, it's saying that the function as x approaches 1 from the left does not exist, or excuse me, that the limit does not exist. The function is there, but the limit does not exist. That's probably because it's like a vertical asymptote, or a like that goes to positive infinity or negative infinity. Okay, so it's very likely that this function is either going, from the left side, it's either going vertical this way, or it's going to go vertical down here, and at 1 there's a vertical asymptote, or at least coming from the left there's a vertical asymptote. Now something weird is happening with h of x, because as x approaches 1 from the right, it does have a limit. It's approaching a height of -4. And so from the left, there's no limit. From the right, there is a limit, and it's -4. So we want to know, well, what is the two-sided limit? What is the limit of h of x as x approaches 1 from both sides? Well, the answer is no limit, or does not exist. And that's because you can't have a two-sided limit unless you have a limit coming from the left and a limit coming from the right. We have a limit from the right, but we do not have a limit from the left. Therefore, we also cannot have a two-sided limit. And therefore, the answer to this is either going to be DNE for does not exist, or we can just simply say no limit, okay? And so that's the basic idea of a two-sided limit. I'd like to do one more example, but not like this. I want to give you an example. We're actually going to, I'm going to put a limit function here with the actual analytical function, and then we're going to use either Desmos or we're going to use a calculator, and we're going to create our tables like we did in day 1, and then we're going to identify the left-sided limit, the right-sided limit, and then we're going to see if there is a two-sided limit. Okay, so let's try and solve this two-sided limit, okay? All right, what we have here is, what is the limit as x approaches 2 of the function x cubed minus 8 over x cubed minus x squared minus 5x plus 6, okay? Now, we learned a technique at the end of day 1 in the very last video where we learned how to find the answer to a limit by substituting in the number. Well, we could try that. We could just take this 2 and put it in for x and see if we get an answer. The good news is if you do that and get a number, you're done. You don't even have to do any of that other nonsense that we learned how to do, okay? So let's go ahead and put 2 in. So 2 to the third power, 2 times 2 times 2, that's 8. 8 minus 8, that's 0. Okay, well, we got a 0 in the numerator. So now let's put the 2 in the denominator. 2 to the third power, that's 8 again, minus 2 squared, that's 4, minus 5 times 2, that's 10, and then plus 6, okay? 8 minus 4, that's 4. 4 minus 10, that's -6, and -6 plus 6 is 0. And therefore, we have 0 over 0. That's not a real answer. That's what we call an indeterminate form. And what that means is that we have more work to do. So now what we're probably going to have to do is we're probably going to have to create a couple tables of values. We're going to need to do the left-sided limit and the right-sided limit of 2, okay? So on the left side, numbers smaller than 2, maybe we can put in like 1.9 and 1.99 and 1.999, right? And then on the right side of 2, why don't we put in 2.1, then 2.01, and then 2.001, right? And we're going to have to plug them into this crazy function right here, which is x cubed minus 8 over x cubed minus x squared minus 5x plus 6. Okay, and we got to kind of do that on both sides. X cubed minus 8 over x cubed minus x squared minus 5x plus 6. Okay? All right, now we can use a calculator to do this, or we can use Desmos, and here's what I'm recommending. I'm recommending, why don't we break over to the computer and let's do this in Desmos, because I think this can be sort of crazy in the calculator. Desmos can do it much faster. Okay, here we are in Desmos. So let's go up here and we'll key in our function. Y is equal to, let's see, let's create a fraction first, 2 over 3, but now we're going to make the numerator x to the third power minus 8 over x to the third power minus x squared minus 5x plus 6. Now here's the cool thing. We could actually find the answer to this graphically by coming over here to where the graph is, but I really want to use the table technique. So remember what I said, you can click on this edit thing, you can copy it, so you have 2 of them, and turn one of them into a table, right? And so now we want to do the left side and the right side. Well, let's do them separately, okay? So what we'll do is this, we'll eliminate this and this, we only need 2 of them. So in the left side, first we put in, see, we were approaching 2, so we had 1.9, Is that correct? And then 1.99 and then 1.999, right? And so if you really want to, we can put in one more. We can put in 1.9999, and that could help us a little bit. But you can see here, we got 4.545, then we got 4.047, then 4.004, and then 4.000. It seems pretty clear to me that as x is approaching 2 from the left, that the function itself is approaching a value of 4. Okay? And so our left-sided limit is going to be 4. Okay? All right, so now let's try as we approach 2 from the right. All right. So let's start with 2.1, and then 2.01, and then 2.001, and then maybe 2.0001 if we have to. And yeah, so see what we have here? As from the right side, as we get closer and closer to an x value of 2, we got 3.59, then a 3.95, then 3.99, then 3.999. It looks to me like from the right side, we are also approaching 4. Okay? All right, so let's go back to the whiteboard, and we'll see if we can get a final answer for this two-sided limit. All right, so I've gone ahead and filled in the information that we just got off of Desmos. And so we can see here that as x is approaching 2 from the left, that our function, it looks like it's approaching 4. So as the x is approaching 2 from the left, the function is approaching 4, okay? And over here, as x is approaching 2 from the right, the function is also approaching 4. And so what we're seeing here now is that the left-sided limit is 4, the right-sided limit is 4, and so when we go all the way back up here to what is the limit as x approaches 2, this is a two-sided limit, right? It doesn't have the notation up here, so that means that this is asking what is this function approaching as x approaches 2 from both the left side and the right side, and since both of those numbers are 4, the answer to this limit is 4, okay? And that is the basics of how a two-sided limit works, or what is a two-sided limit. What we're going to do now in the next couple segments is we're going to look at how to solve two-sided limits when I give you limit problems. We're going to look at how to do it graphically, and we're also going to look at how to do it analytically.